In this short lecture, we're going to look at several examples of how to compute cross products of vectors. Okay, as we have seen in earlier video and also in our textbook, if you want to find the cross product, we use either a determinant method or we use the rules that we have over here. These are the rules, which is equivalent. Okay, so let's first review what we had. Suppose you have A over here is equal to A1, A2, A3, and B is equal to B1, B2, B3. Then A cross B is going to be a vector, and the vector is computed this way. This is I, J, K. This one over here is the basis vectors, and then you put A1, A2, A3 over here, and B1, B2, B3 over here, and then you calculate the determinant using the rules. Okay, we will show example over here, but let's look at what the first problem is asking us to do. Find a vector that is perpendicular to both vectors, and we have P and Q and R over here. So first we need to find these two vectors, because we know this can be done by finding the cross product, because cross product is perpendicular to both vectors. So let me call this one simply A, and A is going to be PQ. Okay. Now remember PQ, that means P is the tail and Q is the tip. So we use the point of Q and subtract P. Okay, so this is going to be -2 minus 1, -3. 5 minus 4 is going to be 1. -1 minus 6 is going to be -7. Okay, and this is A, and B over here, and this one is going to be PR. So the tail is P and the tip is R. That means we use R's coordinates and subtracting the coordinates of P. So what do we have over here? It's 1 minus 1, which is 0. And then we have -1 minus 4 is -5. And 1 minus 6 is -5 as well. So now we're going to find a vector. We call this vector simply V. Okay, V is going to be perpendicular to A, and V is going to be also perpendicular to B. And you can use V equal to, this is just one choice, of course. Okay, and then this is going to be equal to I, J, K. And then we put A's vector over here, -3, 1, -7, and 0, -5, and -5. Okay. All right. And then we say we expand over the first row. So this is going to be 1, -7, -5, -5, and times I. Okay. Remember, the second one is going to be negative, so it's going to be -3, -7, and 0, -5, and J. Okay, so what we are doing is that remove the jth column over here, and then put these numbers over there. The last one, let me squeeze it over here. The last one is going to be plus minus plus, right? And then we have -3 and 1, 0, -5, and K. Okay. Because these are vectors, maybe we want to put vector signs on top. These are vectors. Okay, I, J, and K, the vectors. All right, so let's finish the computation. So this one, V over here, the determinant, -5 minus 35. So let's write down first because, all right, that's I. That's going to be easier. One thing at a time. 3 times 5 is going to be 15 because negative sign is just negative, negative. Become positive, and then this is 0. Okay, so this is J. Last one. Again, we have a 0 over here. That's really nice. So we have plus. Again, it's 15. Okay, that's fine. And 15 over here is going to be K. Okay, so now if we put together over here, then we have over here is negative 40 I and negative 15 J and plus 15K. Okay, or we can simply write down negative 40, negative 15, and 15. Or we can factor the 5 out, so we can negative 5 out is scalar multiplication, so we can actually get 8 over here and 3 over here and negative 3 over here. So we know that if you multiply a scalar factor, it's not going to change the factor's direction. So we can choose. So we can choose actually this one. So that's the final answer. We can say we have 8, 3, negative 3. Now, it's possible we have made some error over here. So we're going to try to verify. Usually it's not necessary. So let's look at, suppose this vector over here, we can call it still v over here. Let's try to check if a dot v is going to be 0, because this is going to be negative 3 times 8 is negative 24. And then we have plus 3 over here. And then we have over here plus 21. I is equal to 0. It's checked. Okay. How about b dot v? Okay. And that's going to be 8 times 0 is going to be 0. And this is negative 15 and plus 15. And that's going to be 0 again. So it's checked. Everything is okay. All right. Let's pause and then we move on to next problem. Okay. In the next problem, we are saying use the rules. I cross j is k, j cross k is I, and k cross I is equal to j to find the cross product of a cross b, and a is 1, 0, negative 3, and b is that. So-called using this one over here is simply using the distributive law. So we're going to rewrite a over here is equal to 1i plus 0j and minus 3k. So that's what we have. Okay. And b, again, we have 0i. So this one over here is 0i minus j and plus 2k, right? I, j, k's are simply these so-called standard basis factors, right? And then we're going to do a cross b, and that's going to be I minus 3k and cross negative j and plus 2k. Yeah, once we have this expression over here, the rest of it is simply a distributive law. So we're going to do the following thing first. The first one, we're going to have I cross negative j, and then plus I cross 2k. Now, constant factors can be put in the front, so we're going to do a little later. And then minus 3k cross negative j. And then last one is going to be negative 6k cross k. Okay. Now, we need to remember one thing is that I cross I is equal to 0, j cross j is equal to 0, and k cross k equal to 0. So all these things are 0. So now we're going to have I cross j is negative. So we're going to have negative k, and then plus 2. I cross k is k cross I negative, and k cross I is j, so this is negative j, in the middle, the second one. And then negative 3, negative 1 is going to be positive 3. And look at kj, supposed to be jk, so this is going to be negative I. Okay, k cross j is negative I. And the last one is 0. So now we put them in the order. So this is going to be negative 3i and negative 2j and negative k over here. So we have this cross product is negative 3 and negative 1. Now, do we need to verify this is true using the determinant method? Probably yes, but I think we're going to save time and leave the verification to you to finish. All right, that's all.